Hi, this is Steve Michelotti of the Azure Government Engineering team. I'm joined here today by Chris Pendleton, Principal PM Manager of the Azure Maps team. Welcome, Chris.
Thank you.
So we're here to talk about Azure Maps on Azure Government.
Yeah.
Everyone knows what a map is, but why don't you start out by just helping us understand what is Azure Maps specifically?
Yeah. So Azure Maps is the now government platform for mapping at Microsoft inside the Azure cloud. And so what we did was we basically stood up instances of our map stacks in partnership with a number of companies and brought mapping capabilities to the Azure cloud natively. And so now we're running these services natively in the Azure cloud. And what we wanted to do was extend those capabilities to our government customers. And so now what we have is a super robust set of location-based services running natively in the Azure cloud for our government customers to use.
So not only are these native in Azure, you're getting the power of the cloud, but you already have an Azure Government subscription, easy to provision Azure Maps.
Exactly. You can just log into the Azure portal for government and spin up an Azure Maps account instantaneously.
All right, awesome. All right, so what else we got here?
Right, so Azure Maps is a very robust suite of capabilities. Maps, of course, are natively inherent in the mapping platform. We've spent quite a bit of time investing in the vector geometry that goes into the map, so it's super, super robust. We also have satellite imagery included as a part of Azure Maps. And that's all actuated through a set of SDKs. So today we have our web SDK. That pulls down all that vector data and renders it into a map, as well as the imagery. And then all of the services actually come to life in the SDK, right? So when you want to connect to any of the Azure Maps services, you could do that through our Azure Maps SDKs. The Azure Maps SDKs actually have quite a bit of robust capabilities as well. So when you want to render push pins or points, you want to render lines, you want to render polygons, you want to render multiple layers of data, multiple layers of polygons, intersecting polygons, raster images, all that actually is natively included as capabilities in the Azure Maps Web SDK, as well as the Android SDK.
Okay.
And so when we get into some of the functionality, you're going to find that it's quite robust. So if I move on to the routing service, for example, our route service has multiple algorithms. You can request a route from A to B. You can request a route from A to N, meaning multiple points along a route. We'll even do route optimization for you. So if you have a number of stops, you're not sure what order in which to do that, you submit those to us and we'll actually do the calculations for you. We have truck routing attributes included as a part of the route service as well. And then for some of the more advanced algorithms like isochrones. So isochrones is basically, I am here, where can I get to in 1 minute? 2 minutes, 5 minutes, 10 minutes in all directions. That ends up being a polygon. And from that polygon, you can then filter information for the things that you can do within that polygon. And as an example, I wanted to kind of dive into some of the routing capabilities, actually, because it is sort of the tip of the iceberg, if you will. So if you look at some of these capabilities, like we will do algorithms for the fastest route or the shortest route, which are not always the same thing. You can have fuel-efficient routes, thrilling routes. All of these are built in. You can set a departure time that you have to leave at, or an arrival time, which means if traffic conditions change, we'll actually provide notifications to you if you say, I have to be catch a plane, for example, and there's an accident all of a sudden. We also have pedestrian routing. So if you're a pedestrian, you want to include that into your route calculation. That's natively included in the service as well. I mentioned truck routing, but truck routing is a very deep area when it comes to routing. There's quite a bit of attributes that go into that. So for Azure Maps, we support maximum speed of a truck, the weight of a truck, the axle weight, the vehicle length. These are all attributes that you pass in, and will calculate the best route for trucks. So that's unique from vehicles, and it's unique from bicycles. We also have bike routing as well, pedestrian, right? Like these are different. These are very different parameters that you need to use in order to calculate routes specific for trucking.
Right. Yeah, it's interesting. As I saw the last slide you had where it was just the icons, I saw an icon for routing, and you think, okay, it's directions. But then when you see a slide like this and you see, it's not just directions, there's a lot more that goes into it. It's really mind-boggling how many variations and how efficient you can get with some of these precise calculations. So it's
Yeah.
super interesting to see that.
Yeah, my icon slide is a bit of a cheat slide because there's so much under the covers there
Right.
that come with this, and you're seeing some of them now. Just being able to avoid things and being able to use traffic in your route calculations.
Yeah.
These are complex algorithms that we provide natively as a part of this.
Yeah, and we peeled back the layer on that one route icon on this slide, but I imagine we could probably do that for every one of those icons if we had, all the time.
Absolutely.
So, okay.
Yeah, and moving on to search, that's another example. So I did want to mention we have this very deep partnership with TomTom, a company out of Netherlands, and as a part of our partnership with TomTom, they're providing these services under the covers. And so what that means is, as a part of, say, the search service, we have access to every piece of information that TomTom has ever collected and made searchable in their APIs through Azure Maps.
Oh, wow.
And so that means every address, every landmark, every place. These are also reversible. So if you have a coordinate, I'll tell you what intersection you're at, what address that's at. And these can be done in batch as well. And so if you look at some of the under the covers or tip of the iceberg things for search, same kind of thing, where you've got a ton of capabilities, a ton of data, and a ton of different ways in which you can filter that data when you're trying to get to the point of what you're looking for.
Right.
You can actually filter down to exactly what you're looking for.
Yeah. Okay, cool.
Yeah.
All right, let's keep going.
Yeah, we introduced spatial operations as well, and so spatial operations is two things. One, it's spatial calculations, so being able to analyze data. Maybe it's you've got a point and you've got a number of other points. You want to know what's the closest to that isolated point.
Yeah.
These are great calculations. We have Haversine calculations because, as it turns out, the Earth is round. Some people don't believe that, but it is, and so we calculate for that. We also have a geofencing service built into our spatial operations. The geofencing service allows our customers to upload fences or invisible geometry into the cloud, and then ping that service with GPS points to know, is this point in that fence, and then create a series of alerts as a result of that. And so the geofencing service is super well received in the enterprise and highly applicable in government when you want to know where things are and where they're not and when they should be there. And so there's a time aspect for geofencing.
Yeah, just the logistics aspects alone, that's huge. I mean, logistics that's what so many aspects of our government are based in that. That is a huge area. And that's another example where Maps isn't just about seeing maps or knowing driving directions. It's really about the precise decision making you can get with using all these additional built-in services.
Absolutely, and I got a demo of that later.
All right, great.
So we'll take a deeper look at that.
Cool.
We have a traffic service, so all the traffic flow for dozens and dozens of countries around the world, where you've got street level information for the flow information, all the incidents, so traffic accidents, events, construction, all of that feeds through into the traffic API. We're seeing a lot of uptake in the traffic API for smart city initiatives, where you want to just be able to track the flow of traffic through your city. There's a lot of cities that are struggling to just understand how traffic flows through their system.
Right.
And so a traffic service like this, where you're getting massive amounts of information from different devices that amalgamate into a traffic flow, and being able to calculate the time it takes across different
state and local governments, the ones that do have those cities that need to understand traffic patterns better. Perfect example.
Exactly. We have a time zone API. So pass us a coordinate. We'll tell you what time zone it is. We'll tell you what time it is there. We'll tell you the offset to GMT, and we will tell you sunrise and sunset at that location.
Okay.
This is critical for sort of IoT applications for lighting and energy savings and things.
Right.
We have a geolocation API. You pass us an IP address, we'll tell you what country the call is coming from. That helps you customize experiences to your customers, localization, things like that. We have a mobility service. Our mobility service is basically public transit, right? So you want to find the nearest bus stop, you want to find the nearest train station. It also provides real-time information for a number of municipalities. Where is the bus? Where is the train in real time?
Okay.
And we partnered with a company called MoveIt to build out our mobility service. And so under the covers, we're getting actually billions of input from crowdsourced information that feeds into this MoveIt platform that we then surface through Azure Maps and make it available to our customers.
Cool.
And then we have a data storage service as well. This is largely the back end of our geofencing API. So when you want to store geofences in the Azure Maps part of the cloud, it'll just go into the data storage. And we recently announced weather. So weather service, this provides real-time information of weather. You can see radar, you can see infrared as overlays on the map, but you can also see weather information for current conditions. You'll be able to see the future forecast for different areas. And then we will have weather along a route. So given a particular route, you'll know what the weather is for a certain amount of time as you're driving that route. And so
just being able to get all those in one subscription, one cloud provider, not have to have 50 different licenses or subscriptions to different customers. And I mean, just being able to have all of that integrated in one solution is just a huge efficiency, time saver, if nothing else.
It really is. And I should mention, our weather service is powered by AccuWeather, the best weather company. And they've won multiple awards to prove that. We surface their weather because weather becomes a significant signal for a number of scenarios, ranging from agriculture to automotive and transport. So weather is a critical aspect, and you don't have to negotiate with TomTom and MoveIt and AccuWeather, Azure Maps, and we bring all these Azure Maps capabilities as well. You just need an Azure Maps subscription.
Awesome. Okay, great.
And then I should mention we also announced integration with Power BI. So for Power BI, customers that use Power BI, Azure Maps is there as well.
Great. All right, great. Let's keep going.
Great. So let's go into some of the applications of Azure Maps. We sit inside of the Azure IoT organization, and so when I think about maps and location, I think about IoT. And inside of Azure IoT, we actually think about three aspects of the evolution of installing devices. So one is the device sensors themselves. Those device sensors emit a ton of information, right? Whether it's temperature or humidity, whatever it is, they're emitting all of this data out so that you, as a customer, can make data-driven decisions, right?
Okay.
So that data is pumping up into Azure and you're making these data-driven decisions. That's great. We bring a filter of location. So not only are you seeing devices that are producing information and you're making decisions, we filter that out so you know where to make those decisions.
Yeah.
You know where those devices are in the real world, and you could apply a filter of location on top of your IoT data.
Nice. Okay.
And we call that the location of things. It's a great concept because it does intersect location and the IoT world.
Yet another example of having everything cohesively work together in the cloud.
Exactly right. That's right. And so this is a sample of vehicle telemetry coming in. This will feed into a demo, and so this vehicle telemetry comes up in through IoT Hub. So Azure IoT has IoT Hub, which basically receives messages. We'll take those messages and send it over to Event Grid to check. This particular demo or this particular stack will actually walk through what it's like to track a vehicle. And so what we want to do is, if this vehicle has left the geofence, send an alert. And so the stack, when you walk through this, telemetry is coming in, IoT's taking it in and submitting it back. We check it with Event Grid. Event Grid is actually calling an Azure function that calls Azure Maps. And Azure Maps is checking, is this GPS coordinate in the geofence or not? So you'll get the constant reading, it's in, and as soon as it goes out, you get a cascade of events that you as a customer can control. These could be alerts, these could be text messages, emails, these could be other cascading events. Yeah. Notifications to others, this could be reroute other things, determine the directionality, things like this.
Okay. So this vehicle could be a police car, it could be a Humvee, anything that we integrate with IoT Hub, we can track.
Exactly right.
Okay,
That's
cool.
right. Good. So I wanted to demonstrate this because we are seeing vehicles getting connected more and more every day. And where those vehicles are actually matters, right? So I think in government scenarios, it's important to understand not just where they are, but where they aren't, and where they are, where they should be. And that's where this geofencing demo can come in pretty handy. But you can also think of scenarios where you just want to know when they're close. you're tracking a particular vehicle and you want to know where they're close. So let me demonstrate geofencing in this context. And so what I've got here is a sample application. I've set Bethesda as an origin. I've got the White House as a destination. I've got a radius of the geofence here, 3 kilometers, and I'm just going to hit play. And what this does is it ends up calculating a route from Bethesda to the White House. It's going to animate the telemetry of a vehicle. So this is a simulation, if you will, where we took the route geometry that was created by the route service and pushed it back, and now we're just tracing through. And this is a car driving through, and as it approaches the geofence, you'll see, boom, it kicks off an alert. I have now entered the fence. And so this could cascade into a number of events. And then once it arrives at the destination, another alert kicks off.
And I saw you had a 3 kilometer radius. I presume you can configure that. And
Absolutely. So the 3 kilometers, totally arbitrary. It could be a circle. It could be a bigger circle. It could be a polygon.
Oh, wow. Okay.
We see a lot of routing scenarios. So like if a truck leaves a route, an alert kicks off because I want to know. This is great in shipping scenarios as well. So this is all geometry based, and so it doesn't matter that it's over the ocean or over land, right? So this could be a shipping container or an actual ship vessel that is traversing over the seas, and if it leaves a projected trajectory, we can actually get a notification. Maybe there's something going on.
Okay, cool.
Right.
All right, what's next?
Yeah, so I wanted to actually cover some of the compliance factors that went into shipping Azure Maps in the government cloud. This is an important factor, and it's actually not easy to achieve, right? But we are fully cloud scale. So when we talk about cloud ready, we're talking about cloud scale. We're talking about global availability. We're talking about a web and mobile SDK fully integrated with other Azure services as well. So when you come to Azure and you want to use Azure capabilities, Azure Maps is probably integrated to other services as well. And then trusted security services. This is all the compliance factors that actually feed in, not just security, but we are fully security compliant when it comes to Azure. We have Azure Active Directory tenancy as well. GDPR compliant, so when customers want to check that box, it's important. We are fully compliant with GDPR. And then for accessibility, usability, globalization, these are all factors to ship in Azure, and they are a little more stringent when it comes to the government cloud. I should say that the Azure Maps Web SDK actually got a grade B for accessibility. It's only the 9th product to ever do that. And so we're pretty proud of that, and wanted to make sure that was aware that accessibility is an important feature for us as well.
Great. All right.
Cool. The other thing I wanted to talk about is this the code samples site.
Okay.
So first of all, mapping and these services can get a little complex, and so we've built a site dedicated to government customers who want to code against Azure Maps.
Great.
And so what I'll go through is a few of these demos, but I did want to at least flag the fact that this site is out there for government developers who are starting to integrate this, and for business decision makers who don't know how to code. So our enterprise customers have enjoyed some of the fruits of our labor when it comes to these code samples, and there's 160 plus code samples that have been available to them, but now we've ported that over to the Gov Cloud. So you'll notice that Azure Maps code samples.azurewebsites.us is hosted on the Gov Cloud.
So anyone can go to that. Any customer can go to that URL right now and see these samples themselves.
Absolutely.
Cool.
And what's beautiful about that is it's made for business decision makers as well as developers.
Great.
So if you are a business decision maker, you can come in and check out some of the functionality that is inherent in the Azure Maps platform. As a developer, you can come in, see the functionality, and get the code. Yep. And so we have all of this code running in GitHub. You can go to GitHub. It's freely open available, and you can just grab it and start running with it with your Azure Maps key.
Okay, so let's look at a couple samples.
Yes, absolutely. So first I'll demo a drag and drop GeoJSON sample that we have. So this uses Azure Maps under the covers, of course, and this is our web SDK. And you can go to data.gov to get a bunch of just open source data sets. So linking over here, I can go over and download is a bunch of different sets. I went ahead and downloaded some ahead of time. And so what I want to do is basically grab one of these. This is 2016 election results voter turnout for Virginia. And I'm going to drag this over to the map and just drop it right on there. and you'll see that it just renders natively right onto the map.
Wow. Okay. You just did that right from data.gov.
Right from data.gov. So, and there is a lot. So when you see this GeoJSON icon, all of these are available for download. Grab them, download them, and just drag it onto Azure Maps. It'll just render.
Awesome. Okay.
Yeah. And then, of course, from there, you can jump over to GitHub, and the source code for that specific demo is available right there.
Okay, so any of the demos, I'll have the source code button I can jump over as a developer and look at how to do it.
Absolutely.
Okay.
Yep.
All right. What's next?
Great. So let's move on to heat maps. So the heat maps have some super visual impact, right? When you want to look at data and you want to see it aggregated, we could just jump into this sample, for example. What this does is it keeps the size of the data consistent as you zoom in and out. And so as I'm zooming out, you'll see that it doesn't like grow with me. It doesn't stay. It's actually staying the absolute size that it needs to be relative to the map zoom level.
So even as you're zooming out, zooming in, I'm struck by, as we go through these samples, like just the visual aesthetics on these and just the high fidelity of the visuals I'm seeing is pretty amazing.
Yeah, we spent a lot of time designing Azure Maps. In fact, and not to mention, all of the data coming through in the map itself is vector. And so we don't have any raster aspects of this. This is all tiles. It's all vector data pumped into tiles. And so we're able to control design and rendering on the client, which allows us to get super sharp edges and super crisp renderings.
Much higher fidelity. Okay, yeah. Cool.
Yeah, so this, basically you pull in data, we'll create a heat map for you as an overlay, right? And you can set the translucence and zoom in and out. And again, we've separated the layers of the map as well, so that as you're pulling your data in, you don't lose the labels. This is actually an important thing that a lot of competitors actually struggle with, and they actually put data on top, and you lose all the underlying context. So what we did is we separated the labels layer, and now you can render your data under the labels, but still on top of the map.
Okay, cool.
Yeah.
Let's see another one.
Yeah. So the next one I want to show is a convex hull and markers. And what this actually illustrates is a couple things. One, you could put data on top of the map, absolutely, but then you can control it. So what you're able to do is grab these pins, and at runtime, I'm basically changing the polygons, right? So these pins can control the extents of this particular shape, but also I'm getting events listening into the client. And so what that means is I'm actually getting the coordinates, but I'm also getting the pixel count, and it converts to measurements, right? So now I can measure the actual perimeter of this particular shape. And I can move these around as I'm trying to pull this into a concave hull. But it also measures the area, right? So as I'm manipulating the data on the map, which is fully flexible, I can actually do calculations on top of that as well.
And I can just drag and drop around. I don't have to do all the math myself in advance.
Take care of that for you.
Okay, great.
That's right. So the last demo I wanted to show you is our weather. So I mentioned we recently announced our weather service. And so I'm going to click over to this particular demo. And what you'll see here is our map. By the way, we do have multiple styles of the map. So our normal cartographic map, which you were commenting on, we also have a dark, we have a night, we have a couple grays. What it does is it makes your data pop. Right? Yeah. So if you look at this weather information that's overlaying on top, this is radar information overlaying on top of the Azure map. And I'm going to zoom out so you can see it's data for the world.
Yeah.
So we're getting all of this data globally. And we also have infrared information as well. So you can get heat signatures rendered on top of the map.
Okay.
Select that. There we go.
Oh, wow, and there's the infrared right there.
So there's infrared coming in. Yeah. And again, fully scales with the map, comes as another layer, and your labels stay on top.
Okay, great. Yeah. So in addition to, of course, regular documentation, probably an area to get started is this website right here, the Azure Maps codesamples.azurewebsites.us. So this has been Steve Michelotti with Chris Pendleton talking about Azure Maps on Azure Government. Thanks for watching.